Hello, my dear students. Welcome to Science Made Simple by Ms. Flonks. Our today's standard 6.E.2a.2 analyzed based on evidence how different phenomena, natural and human-induced, may contribute to the composition of Earth's atmosphere. I mentioned in the first video that this standard is divided into 3 topics. They are the origin of the atmosphere, the ozone layer, and the greenhouse effect and global warming. Looking back, our topic on origin of the atmosphere is actually the natural induced phenomena that contribute to the composition of the Earth's atmosphere. If we recall, the carbon dioxide in the atmosphere came from volcanic eruptions during the early Earth. The oxygen in the atmosphere came from the photosynthetic organisms that existed later during the early Earth. And the nitrogen was added to the composition of the Earth's atmosphere from the decomposition of dead plants and animals. Now our focus now is this human-induced phenomena that contributed to the composition of the Earth's atmosphere. What is our cross-cutting concept? We are still on the cause and effect. We look at what caused certain process and what will be the effect if that certain process takes place. Our lesson for today is about the ozone layer. But then, let's go back first to what is atmosphere. The atmosphere is a layer of gases that surrounds the Earth. If you look at this illustration, this is the Earth, and these are the layers of the atmosphere. The one closest to the Earth is what you call the troposphere, followed by the stratosphere. Next, the mesosphere, the thermosphere, and the exosphere. Our current atmosphere is different from the early atmosphere. Recalling what we learned about the origin of the atmosphere, during the early Earth, where there's no atmosphere yet, only volcanic eruptions. This is the reason why carbon dioxide is very abundant with 85% of the early atmosphere. And you notice that oxygen is not found during the early atmosphere, simply because there is still no photosynthetic organism that existed during this time. What are photosynthetic organisms? These are organisms that are capable of performing photosynthesis. And what is photosynthesis? That is the process wherein plants make its own food. But this natural phenomena like volcanic eruption contributed to the carbon dioxide to the atmosphere. But it's not only that. As the Earth cools down during the origin of the atmosphere, photosynthetic organisms, the microbes, the cyanobacteria, started to perform photosynthesis using carbon dioxide in the atmosphere and thereby releasing oxygen. And that started the addition of oxygen to the atmosphere. And that changes now the early atmosphere to what we have right now in the current atmosphere. During those times also, in the early atmosphere, nitrogen is just 1%. But if you compare that to the current atmosphere, nitrogen is 78%. And what natural phenomena caused this to happen? Decomposition of dead plants and animals. So those are natural phenomena that contributed to the changes of the composition of our atmosphere. And now we'll look at the human-induced phenomena. So let's go first to What is the ozone layer? The ozone layer is a layer of gas consisting of 3 oxygen molecules, and that is what we call the ozone. So this is the ozone. When they come together, they will form the ozone layer. Ozone can be created or destroyed by the sun's ultraviolet rays as shown in the picture to the right. Look closely. And what are these ultraviolet radiation? These ultraviolet rays penetrate the Earth's atmosphere at 3 slightly different wavelengths called UVA, B, and C rays. These UV rays consist of 3 types. You have the UVA rays, which is the most common, the UVB rays, the UVB rays that cause sunburns, cataracts, and immune system damage, and the UVC rays, which is the most dangerous. And good thing that these UVC rays are being absorbed by our ozone layer. So why is the ozone layer important to life? The stratospheric ozone layer is called stratospheric because they are found in the stratosphere of our atmosphere. Completely stops the penetration of UV rays. Remember, UVC rays is very dangerous. So thankful to our ozone layer because these UV rays cannot reach the surface of the Earth. Eliminated most of UVB rays. So the UVB rays can enter and pass through the ozone layer, but not that much, whereas the UVA rays can enter the ozone layer. Therefore, the ozone layer protects life on Earth from the harmful effects of solar radiation on a daily basis. So this is how our ozone layer helps us, or how important the ozone layer to life on Earth, simply because they act as a protective layer that only allows few UV rays to enter and reach the surface of the Earth. So now, what are human activities that cause changes in the composition of the atmosphere, affecting our ozone layer? So we said earlier that the normal composition of our atmosphere should consist of only 78% nitrogen, 21% oxygen, and 1% other gases that include carbon dioxide. And that should be the ideal. But because of human activities, specifically carbon dioxide, the gas that can destroy our ozone layer, can change now the composition of our atmosphere. So what are those activities that can cause the change in our ozone layer? The depletion of our ozone layer. When we say depletion, that is now the change in the composition of our ozone layer, the thinning of the ozone layer. And if that continues, then ozone hole will be possible. So what are those activities? We have deforestation. Deforestation means when you cut like more trees and convert that into buildings and other commercial sites. Thereby, now, if you cut those trees now, there will be less trees that can make use of the carbon dioxide in the process of photosynthesis. The CFCs also will be released to the atmosphere that breaks the ozone from each other. The oil and petrol engines, this is the fumes coming from your vehicles, and as well as the greenhouse gases and fossil fuels from these factories. All of this can contribute to the depletion of the ozone layer. So what do you think will happen if our ozone layer will be depleted? So temperature changes and rainfall failures on Earth. There will be climate change. There will be crop and forest damage. There will be less ocean plankton. Plankton are microscopic organisms in the ocean. It could be a phytoplankton and a zooplankton. Less fish harvest simply because of the increase in the temperature of our water level. Infections and skin diseases on animals. Reduction in plants' chlorophyll. Marine ecosystem disturbance, and microorganisms may get harmed as well. So basically, from the very minute microscopic organisms to the biggest organism on Earth, we will be all affected if our ozone will be depleted. Because we learned already that the ozone layer protects us from the harmful UV rays. What if it will become thin, or even there will be a hole on it? So there will be no more layer that will protect us. And these UV rays can go straight on the surface of the Earth. So if we look back now to our standard, analyze based on evidence how different phenomena, especially the human-induced, may contribute to the composition of the Earth's atmosphere. So looking back on the activities that we have discussed, so this basically will release and add carbon dioxide, methane, and other gases to the atmosphere. These activities that we have mentioned will add to the composition of the atmosphere, will add to the gases that is found in the atmosphere. And what are those gases? Carbon dioxide, methane. They are responsible of destroying our ozone layer. When increased carbon dioxide in the atmosphere, they will trap more heat, thereby causing these effects now. And basically, it is the increase in temperature that can cause a domino effect to the very minute microscopic organisms to the biggest organisms on Earth. So going back again to our standard, so those are activities, human-induced phenomena, human activities that contributed to the composition of the Earth's atmosphere. That will be all for today. Next video to watch, the greenhouse effect.